Hi everyone. Today we're going to talk about how we remove discontinuities from a function. And so really the big idea with these problems is you're going to notice that you'll be given the definition of a piecewise function, but there'll be some unknown constant. And our job is to find the value of the constant that will make the function continuous everywhere. So we're going to go through probably about 3 examples in this video just to make sure we've got the idea down. So here's what we want to do. I know that the place that this is possibly going to be discontinuous is at 2 because that's our breaking point. So if I'm going to have a potential discontinuity, it's going to happen there. So I'm going to set this up like I'm checking for continuity at x equals 2. So that means I have to have 3 conditions. I know for it to be continuous that the limit as x approaches 2 from the left of f of x has to be equal to the limit as x approaches 2 from the right of f of x, and then those limits have to be equal to the function value. If I don't have those 3 things equal, then I don't have continuity. So let's see what this is going to look like. If I'm checking that limit as x approaches 2 from the left, I know that's defined by this first piece of the function here. So now I'm checking my x value is 2, so I'm going to plug that in for x. So that means the limit from the left is 2k. Now the limit as x approaches 2 from the right, obviously that's for x greater than or equal to 2. So I'm going to use the second piece of the function, and again I'm going to plug in 2. So I'm going to have 3 times 2, and that's going to be squared. So 2 squared is 4 times 3 is going to be equal to 12. And in this case, f of 2, since this is f is greater than or equal to 2, that same value is going to be the function value. So again, back to our definition of continuity, I know that all 3 of these things have to be equal for that function to be continuous. So what that does is it gives me an equation 2k equals 12, that must be true, so we're going to solve that and we get k equals 6. So in other words, if I made my constant 6, then this function would be continuous. And we could check that. If this were now 6x, now my limit as I approach 2 from the left would be 6 times 2, which is 12. My limit as I approach 2 from the right is 12, and we know we've done it correctly. So that's an example where we just kind of have a single variable that we need to sort out. Number 2 is going to be a little different because if you notice here, now we have a value of a and a value of b that we have to find. But our process for doing that is going to be just the same. So again, my potential point of discontinuity is going to be at x equals 3. So we're going to check the limit as x approaches 3 from the left, limit as we approach from the right, and our function value when x is equal to 3. So 3 from the left, that's where x is less than 3. So now I can substitute my 3 in, and 3 times 3 will give me 9. If I approach from the right, now I'm looking where x is greater than 3. So I'm going to substitute 3 for my x value. 3 squared is 9, so my limit is 9 plus b. And now, because of the way this is defined, f of 3 I know is equal to a. And again, to be continuous means that all 3 of these pieces have to be equal. So here's what I'm going to do. To find a, if all of these are equal, that means a must be equal to 9. So there's one of my constants. Now, if a is 9, then I know that 9 plus b I can set up as equal to a, but we just said that 9 plus b equals 9 because a is 9. So now that tells me that my value of b is 0. And so again, we found the 2 values that if I plugged them into our function would make that function continuous at x equals 3. All right, we'll do one more together. This one's going to be unique because it's going to require us to solve a system of equations, so I think this is a good one to go through here. All right, same setup. We have some constants. I have an a and a b. We need to solve for those values so that the function is going to be continuous, and the point that I'm going to be concerned with here is 2. So I'm going to set up my table where I'm comparing my limits with the function value. And let's see what happens here. So 2 from the left. Now we have to be careful of the order here. That's actually this piece where x is less than 2. We're going to plug in 2 for our x. So that means I'm going to have b minus 2 squared is 4. So b minus 4a for that limit. As I approach 2 from the right, that's up here. Again, my x is going to be 2, so I have a plus 2b. And then my function value when x is 2 is 3. And so these things all have to be equal. So what I get from this is a system of equations. So I have b minus 4a equals 3, and I have a plus 2b is equal to 3. And I need to solve the system. Now, hopefully you remember there's 2 ways of solving a system. We can use substitution or elimination. I'm going to use elimination in this video, but we can talk about both methods when we're in class. So, I'm first going to rewrite this because to use elimination, I want my b's over my b's and my a's over my a's. So I'm going to rewrite this as b minus 4a equals 3, and here I'm going to put 2b plus my a is equal to 3. Now, since these already have opposite signs, my a's, I want those to cancel, which means I'm going to have to multiply everything down here by 4 and everything in my second equation by 4. So rewriting one more time, I get b minus 4a equals 3, and I get 8b plus 4a is equal to 12. And so now we're going to add. My b plus 8b gives me 9b. Negative 4a plus 4a, those cancel, which is what I wanted. And 3 plus 12 is 15. So now to solve for b, I'm going to divide by 9, and I get b equals 15 over 9. So I've got the value for b, and now I need to go back and find the value of a. I'm going to use one of my equations. It doesn't really matter which one we use. And I'm going to plug b back in. So maybe I'll use this one because a is already by itself, and that's what I want to solve for. So I have a plus 2 times 15 over 9 equals 3. So really I have a plus, 30 over 9. Now, I'm going to go ahead and give this a denominator of 9 as well, because I know I'm going to have to subtract this fraction. So 3 is the same as, 27 over 9. I'm going to subtract 30 over 9 from both sides. So I'm going to get a equals negative 3 over 9, which is the same as negative 1/3. Now again, that's just one way of solving that problem. We could have used substitution, and if anyone wants to see that method, we can talk about it in class tomorrow. So we're going to leave this as just a short video. We'll talk about number 4 back in class. Use that. It's going to be slightly different again, and I think it'll help us clear up any questions that you may have. So just make sure you've got these 3 examples down. If you want to try 4, you can, but we'll talk about that in class. All right, thanks, and see you then.